Let's work out some questions on functions. A function f is defined by f of x being equal to x minus 1 over x, where x is a member of real numbers and x cannot be equal to 0, x cannot be equal to 1. So the first one, we want to find f of x. Now how are we able to work out f of x? So to be able to work out this one, what we are going to do is we are going to get f, we put it in f. So we have got a function f, but at every point where we're able to see an x, we are going to put a function itself. So at those points we are able to see an x. So the first one, we have got x minus 1 over x. So where we are seeing an x, I'm going to put the function f itself. So this is going to become what? I'm going to get a function f which is x minus 1 over x. I have put it here where there is x. Okay, the whole of this one minus 1, we are able to see a 1 here, and then divided by x again. But where again where we're able to see x, I'm going to put x, the function f, x minus 1 over x. So just get to simplify this one. This is going to give us, I can remove the brackets, that will be x minus 1 over x, then minus a 1 here, divided by x minus 1 over x. I should be able to match this as a single fraction, the one on top, that is over 1. So I'll get this one multiplied by this, that is going to give me just the x minus 1, and then I'll get a negative 1 multiplied by x, that is going to give us a negative x, and then we'll multiply this and this, that is going to give us an x, and then in the denominator we also have x minus 1 over x. This will continue, this x and this negative x will cancel, so we'll remain with just the negative 1 over x. Instead of writing this over, I'm going to say divide by, and then I'm going to write this one which is down, which is the x minus 1 over x. And then I can also write this as negative 1 over x. It changes to multiplication, the x goes on top, and then the x minus 1 comes down. So this will cancel with this. Okay, so that will be negative 1 over x minus 1. Now this negative we're able to see here, I can more like multiply on top by a negative, also down by a negative. So what we are able to see is on top we're going to have a positive 1, and then if we multiply this x by a negative, it becomes negative x. If we multiply this one by a positive, it becomes positive 1. So this is the most simplified form of f of x. So that's what I'm going to put. So we're saying f of x is 1 divided by 1 minus x. Now we want to find f of f of x. So that means that if we're talking about f of x, we are first going to get this f. Okay, what we are starting is we get this f, we take it into f. The result, we are going to take it into f. So what we have here, we've already found f of x. So we're just going to get this result and put it in f. So that's the meaning. Okay, so this is going to give us, what's the function f? The function f is here. So we're going to get that where there is x, we're going to put this, because that is the f of x. So we're going to say 1 divided by 1 minus x. This is, I'll put where there is x at this point, and then we'll say minus 1. Okay, minus 1, and then in the denominator also we have got an x. So we're going to put again 1 divided by 1 minus x. Okay, and then we'll now continue simplifying this one. So this will give us, again we'll say over 1, we'll multiply 1 by 1, which is going to give us a 1, and then we'll multiply this negative 1 by 1 and by negative x. So negative 1 by 1, that will be negative 1, negative 1 by negative x, that will be positive x, and then in the denominator we're going to multiply this and this, that is going to give us 1 minus x. So instead of me writing this as in the denominator, I'll say divided by 1 over 1 minus x. So we can see this and this can cancel out, so we're going to remain with x on top over 1 minus x, and then I'll change this into multiplication, and then the 1 minus x goes on top, the 1 comes down, this and this is also going to cancel out. So you see what we're remaining with is x over 1, which is simply x. So this is f of x. Alright, Now we want to find f inverse of x. So we just get f itself, now write it in terms of y. So I'll say y is equal to x minus 1 divided by x. Alright, so I'm going to make x substitute the formula. I'll say this is over 1 and then start crossing and multiplying. 1 times x, that, I mean y times x, that will be yx, and that is going to be 1 multiplied by this, that will be x minus 1. Everything with x, I'll take it the same side, that will be yx minus x, and that will be equal to negative 1. Okay, I'm going to factorize out x because we want to make x substitute the formula. That will be x y minus 1, and that is equal to negative 1. So divide both sides by 1, y minus 1 to remain with x. So x is going to be negative 1 over y minus 1. I can also write this as I multiply on top by a negative, becomes positive 1. I multiply down by a negative, this becomes positive, and the y becomes negative. So it is going to change direction like that. Therefore, can now write the inverse. F inverse of x is going to be 1 divided by 1 minus the, where there is y here, I'm going to put x. So that's the inverse then. We have another one here. Let two functions f and g be defined by, we've got f of x, which is 25 over 3x minus 2, and 1 is less than x, which is less than or equal to 9. So this function is only valid between these 2 points, between 1 and 9. And then you have got g of x, which is equal to x squared, and this function is valid between 1 and 3. Now I want to show that f is a one-to-one function. So to be able to show that f is a one-to-one function, we need to say if f of a is equal to f of b, then the result should be that a is equal to b. If we show this, then we have shown that f of x is a one-to-one function. So we're going to say f of a. Okay, we're going to get the function f. We're able to see that is 25 divided by 3x minus 2. But where there is x, we're going to put a minus 2. And this should be equal to f of b. Again, we'll write it again. That is 25 over 3x minus 2. But where there is x, we're now substituting a b. At this point, we're going to cross multiply. Okay, there's no even need of crossing and multiplying, because if these on top they are the same, then you expect also the denominators to be the same. So since the numerators are the same, I'm going to equate the denominators. 3a minus 2 is equal to 3b minus 2. I'm going to take this to this side, is going to be positive. So see, this is going to be positive, this is negative. Those are going to cancel out. Going to remain with 3a is equal to 3b. Okay, divide both sides by a, by 3, I mean a is equal to b, hence shown. Okay, since we've shown that a is equal to b, hence shown, because the question was saying show that. All right, and then part 2 is saying find the domain of f inverse of x. Now I want the domain of f inverse. The first thing we need to find is the inverse function of f. So I'm going to write f in terms of y. Y is equal to 25 divided by 3x minus 2. We'll say over 1, we'll cross multiply y times 3x, that will be 3xy, and then times 2, that will be negative 2y, which will be equal to 1 times 25, that is going to be 25. Take the 2y the other side, so 3xy is going to be 25 divided by, sorry, not divided by, but plus 2y, because we've taken the 2y the other side. And then here we just want to remain, because we're making x substitute the formula, we're going to divide by 3y both sides. So x is going to be 25 plus 2y over 3y. So I'll now say f inverse of x is therefore 25 plus 2. Where there is y, we'll put x. In the denominator also over 3x. Now we want the domain. So the domain are the values of x for which a function is defined. And for a function, whenever we're talking about a function, it shouldn't be, you should never find this. You don't want a square root of a negative number. The other thing, you don't want 0 over 0. The other thing, you don't want a number over 0. So these are the things that should be out of the values of x which are accepted, or out of the domain. So for this function, the denominator should never be equal to 0. So to find the domain, we're going to say 3x should not be equal to 0. Find the value of x. So x should not be equal to 0. Meaning that we can so write that the domain of this function x is such that x is a member of real numbers but x should not be equal to 0. So x can be anything but not 0. We can also write it like this. If this is a number line, this is 0. We can have any value of x going to the positive or to the negative, but not 0 itself. Meaning that we can also write the domain of this function as from negative infinity to 0, like that, and then from 0 to infinity. We can also present the answer in this way. Okay, or we can just present it like this. So in any of these three forms, we can present the answer. So that's the domain of the inverse function. So the domain of the inverse function is the range of the function itself. So if we look at f itself, this function which is here, the range of this function cannot include 0, and that is going to be the domain for the inverse. And then part 3, find the composite function f of g of x. F of g, like that. So we're going to get g, we put it into f. So what is f? F is 25 divided by 3. But where there is x, we are going to put g. What is g? It is x squared, and then minus 2. So this is f of g of x. Alright, and then the next one is saying, hence solve the equation f of g of x is equal to 2 over x minus 1. So this is f of g of x, and they've told us it is equal to 2 over x minus 1. So just get to cross multiply this times that. That is going to give us 25x minus 25. And that will be this times that. 3 times 2, that is going to be 6x squared. 2 times 2, that is going to be a 4. I'm going to take all the terms this side. So we're going to have 6x squared minus 25x, the 25 positive, and then the negative 4, and that will become 0. So this will be 6x squared minus 25x. 25 minus 4, that is a positive 21, and this is going to be equal